We have here today Martin. He has a presentation about real-time network forensics using. I first read porn. I said, yes, let's go there. Let's sign up being Herald.
Yeah, you can do that as well.
But it is a POM-NG. I don't know what it is.
That's right.
We're going to explain this. Please welcome Guy Martin.
So thanks everyone for coming. POM-NG is actually Packet-O-Matic Next Generation. So it's the sniffing tool I'm working on, and I'll explain how it works with all the challenges that are behind us. So a little bit of the agenda. First, who am I? A little bit about network forensics. I'll do an overview of the tool, talk about the architecture, all the different kind of processing. There are also the output, the future of the tool, and the Q&A. And of course, there's going to be a live demo. So I suggest I start the live demo now. I'm not sure how it's going to work because it depends on the traffic I'll see. But in a way, I got a fallback solution with traffic I've got already. So I'm not sure you can see anything, so I'll try to make it bigger. Is it a little bit better? Oh man, it's... Nah, not really. That sucks. Yeah, alright, that's gonna be different. Yeah, can you read this if I make it huge? Is it any better this way? Barely. Okay, it's gonna be fun. Sorry? Yeah, no, doesn't seem so. It's the biggest I can do. All right. Okay, so anyway, I'll explain all the things I'll do. So first of all, sorry, that wasn't planned. So, okay, did I kill it? Yeah, I killed it. All right, so the plan is to sniff the wireless network here, see what is gonna be happening while I'm talking. So first of all, I'll start the tool. Okay, not in a good way. All right, so I just started by issuing the command POM-NG minus T1, and then what I'm gonna do is add an input. So input add PCAP interface, and I'll call it WLAN0. Okay, I'm not root, so it's not going to work, of course. Of course. Yeah, that's a good start, right? All right. You know what? We'll do it later. Doesn't matter. Okay, so first, too fast. Who am I? So I'm Guy Martin, that has been explained already. I'm passionate about networks. I've been working in networking fields for years, but really I just enjoy looking at packets, hexadecimal dumps, stuff like that, find out what's happening on the network. I'm an open source advocate. I'm only using Linux and open source stuff as much as I can. I love C, because that's the main language I code in. And I've been doing a few stuff. A big project I've been doing is exposing how to sniff cable modems. So that's the modem you plug the TV cable in on a city-wide level. So basically, you can see in my previous talks about that. I use a DVB-C card, plug the TV cable, and sniff everybody in the whole city. And that led me to have a lot of packets, a lot of data, and I didn't know what to do with them. So I started this tool to reanalyze everything, try to parse everything, and see what I could get out of this traffic. And I've been also porting Gen 2 on HPPA stations, so that gave me a lot of input about low-level debugging and stuff like that. A little recap on network forensics. So what's the purpose of network forensic? Well, it's mainly for monitoring the network traffic to gather information. Hopefully everybody knows that. Why I do it? Well, proof of concept, because it's fun and because I can. There are also other tools that do all this network forensic. There's Circuita, BroIDS, Explico. They all don't do exactly the same as I do. They do it sometimes better in certain ways. So it depends. If you're not happy with mine, I surely invite you to go and see those. All right, so a little overview of my tool. It's coded in C mostly and part of LUA. The LUA thing is for scripting, so you'll see it's very useful if you want to extract exactly some information. It's fully multi-threaded, it's modular, so you can code, if you want a plugin for a certain protocol, certain payload you want to analyze, you just code that, and it's going to fit all together in the architecture. It's event and payload based, so that's kind of an approach that I've been discussing with a few people, and apparently it's quite new. Everything that's going to happen in the network will result in an event. Let's say you browse a web page, you do a request, that's an event. You have a response, that's another event. You query a DNS server, you send a query, that's an event. You receive a response, that's an event. And on top of that, there will be analyzers that will see, oh, I had a query, I've got a reply, they both match. Okay, I'll create an event that says, I found a new DNS record and it's valid. The payload, it's like the files, everything that is content based. For example, if you payload can be multiple things. It can be, for example, all the files that you send and receive in an HTTP request. It can be also files into your SMTP session. Like one payload is going to be a multi-part blob, you know, with the multi-part MIME type. And that payload will be even then split into its own little payload so it can extract everything. And it's also a work in progress because there are still bugs, it's still being developed, etc. So how does it work? This is the main architecture. First, you sniff from, you have to capture packets, of course, so you can sniff for various things. Usually you're going to sniff from ETH0, ETH1, can be wireless interface, can be satellite cards, TV cards, whatever you think. Then after that, all those packets are taken and they are parsed layer by layer. So the input will say, okay, this is an Ethernet packet. This is an 802.11 packet. So the protocol that matches this description will be called, and then each and every protocol above that will be called by the previous protocol. So you can really go up to the top, up to HTTP, all the stack of protocols, and you will keep the history of this stack. So it's a lot easier to hack on that layer on. All these protocol parsing, they will generate events, as I already explained. They will generate payload, and they will generate packets as well. The packets will contain all this parsing information, so it can be reused. All these information can be reused in the output to either store a file that belongs to a specific event. So if you say, let's give an example, you have a JPEG that comes, and you can see the EXIF data. You can see it has been taken by an iPhone. You can see it's been taken in this location. And because the payload is related to an event, you'll have an HTTP request event linked to that payload. And in that request, you can see it's coming from Facebook.com. So you can say, okay, no, I want all the images that comes from Facebook and that were taken in that specific area at that particular time with this specific device. That works. If you, other things, if you want to see like, I don't know, DNS requests, if you want to have an history of all the DNS requests that happen on your network, since there is an internal DNS cache that will save all the requests and generate an event each time there's a new DNS request, you can just log all those and then review them back if you want to go in the history of all the requests to see if there was some malicious hostname that was pointing to a botnet or something. So input processing, each input has has its own thread. The packet can be queued into a specific threads. So as I said, it's fully multi-thread. So you receive packets from every single input you have. You can have dozens, it doesn't matter. And then you have multi-threading for all the processing. So all threads receive a packet and they start processing it. And as I'm writing, you can sniff from pcap file interfaces, wired Wi-Fi, DVB interfaces, and also I've added recently Kismet drones. So if you have multiple Kismet drones, you can just connect to them and fetch all the packets. Here's the good part now, protocol processing. So because of well, there are stuff you have to do all the time with protocols. Like you have to keep track of connections. If it's a TCP connection, UDP connection, you have to handle streams, fragmentation, etc. So I've implemented basic API that allow a new protocol, if you code one or if it's supported already, to just reuse those API for connection tracking. Connection tracking works in a way that it's a hash per protocol. So the main challenge here was to find a connection tracking mechanism that was able to work with every single protocol. So usually when you do connection tracking, you match on a source and a destination value. You might match on other stuff, but that almost never happened. So for each protocol, I just simply said, okay, you have to look at this field and this field, take them to, create a hash, and you have a connection tracking object. And this allows to create a connection tracking that goes from IPv4, so you have a hash for IPv4. Then each connection with those two source and destination address are pointing to different TCP or UDP connection tracking objects. And each TCP connection, for example, if it's HTTP will have its own connection tracking object as well. So each protocol can save its own little data about its connection and retrieve the whole data from the below protocols. An example of the protocols that are implemented, Ethernet, of course, DOCSIS, MPEG-TS, very useful if you want to sniff DOCSIS cables or even satellite. You can receive you can point at internet satellite streams. Sorry. And it will recreate all the IP packets based on the MPEG, MPE encapsulation. And of course, if there is another kind of encapsulation you find out, you code it, just that small part, and it will integrate with everything else. So yeah, a few challenges in protocol processing. Well, connection tracking, it took me a few months to find out a good algorithm for that. Like I've been on it for 3 months or more. Eventually works very well, and I'm really happy with that. But then there are more touchy stuff. TCP streamer assembly. TCP, we all know it's complex. It seems easy at first. You've got a packet, you know where it starts, you know where it ends, put it in the queue. Okay, well, you put them all together next to each other, they queue it, and that's it. You've got your stream. Well, not really. There are a few stuff you stumble upon. For example, some RFC oddities. If you look in RFC 1122 in that very section I've written there, you can find out that RST packets, they can have a text that say, oh, I got your connection disconnected because of whatever reason. And okay, well, that's fine, but you don't expect that. So when you reassemble your stream, you put your RST packet back at the queue, and it's got payload, and then, oh, bam, your file is corrupted with some random text that the machine said. There are also reuse connections. So if you guys, hopefully you guys know how TCP works, but as a quick recap, first you have the SYN, SYN-ACK, ACK, and the SYN. You have the sequence in one way. In the SYN-ACK, you have the sequence in the other way. And sometimes the TCP connection got closed and immediately reused. So it sends a SYN, but you have to be careful because the sequence may be 2 gigabytes off. So what do? Because in the TCP processing algorithm that I use, if I miss a packet, what am I going to do? Well, I need to do something with that missed packet. So I cannot just ignore it and forget about it and concatenate everything that's after that. No, I have to insert a gap, like empty data. This way, if you're reassembling a video, it allows you to simply have bytes written with zeros, and the video can just continue smoothly playing while you'll have a bit of crap on the screen, but that will not hurt. so what do I do with this new sequence? It's like fire off. So I have to check that the sequence is not too far off, make sure I know the sequence already and keep the state and everything. It's definitely not easy, especially as well when I've seen machines doing synac, synac, and then they send the ACK back, and then just a few seconds later they send a syn back, and another synac comes back, and you don't know which is the connection that's been negotiated. The sequence are just a few bytes away. You don't know what to do, and it bombs out. It's really, really hard. So if you guys have input on that, if you want to look at the code, feel free to do so. I'll just give here a few challenges, not a lot, but DNS record processing, of course, you can just send DNS reply. They're not authenticated or anything. So I had to make sure first to keep a track of all the queries, and then eventually receive all the response gem on the queries. That was not so easy because afterwards you have to handle the expiration of record. So what do? The main goal here was to I get all these. For example, let me give you an example. You're sniffing an access point. You sniff an access point, and mostly what you'll have, let's say the scenario is the following: you are here, the access point is here, and the client is here. You will mostly not receive packets back from the client. You will only receive the packets from the access point because the client is definitely too far off for you to sniff. So what you will see HTTP reply coming. Those are very useful because they contain, for example, HTTP cookies, which you can reuse for sessions, etc. Well, the problem is that you don't know to which host they connected. Facebook, like if you, I like to use this target because it's a funny one, but Facebook, if you see the DNS record changes every 5 minutes, and you really would have yourself to query facebook.com, see, okay, what IP address correspond to this? What hostname corresponds to this IP address? Is it Facebook? Is it not? So here you will receive the DNS reply because the client asked who's facebook.com, and the IP will broadcast, there it is. You just say you don't care about validity of record because you haven't had the query, so you just accept it. And then it will be in the cache, so when you receive the HTTP response back with the session cookie, the cache will tell you automatically, okay, this IP address is facebook.com, so it can update the event, and then you will be able to store that session cookie in your log. So event analysis, as I already explained what the events were. So all the protocols that parse those events, and also there are event analyzers. So you receive an HTTP request, you receive an HTTP query, you know what to do, which one is which. So the analyzers are able to keep track of those two events, the query, the response, and then create a new event that contains the data for both events. So this way you can have everything in one single event. DNS record as well is one of the event. SMTP auth is a different kind of correlation. In SMTP, you receive comments and replies. So you have the comment, which is like hello. The server will reply 220 hello, I'm blah blah, and then you will keep on. The next command you might do is auth plain, auth login, and you receive the reply, which is going to say okay or not, and the analyzer just listens for those events, correlate them all together, and eventually generate an SMTP auth event that tells you, okay, this guy, client address, server name, server host name, try to authenticate with the plain or the login method, and it used this username and password. That's the most interesting bit, of course. All right, afterwards we have payload analysis. So all those files that you receive, you're never sure what they are. If you look at HTTP reply, for example, on some video website, if you receive video, they actually say it's plain text. This way, when you try to sniff it, it will, well, when you try to capture all the video with other tools, they will see, oh, it's text, I don't care. All right. Well, no, you can work this around. First of all, so you can use those MIME types. but it's not always accurate. So what you can do is use a little bit of magic. As you know, the command file on Linux, it's got libmagic, and you can use that library to identify what the payload is really. So this is all done automatically. When you, in your code, you say, I've got a new payload, I've got a new file, I think it's this, but please do some magic on it. The API will say, okay, I got this. I look at the magic. Oh, okay, it's not that. It corrects the right, it puts the right payload on, and this payload will be able to be analyzed by the actual payload analyzer. And this payload analyzer will say, okay, I got a JPEG. It was flagged as text, but that doesn't matter. I got a JPEG. What am I going to do? Oh, okay, is there EXIF data, etc.? And it will feed all those data into the payload object, and you will be able to receive all these information in your in your output that you will script in LUA. I'll see you later. I'll show you later. It's very easy. You just say, okay, take this data. I want this data. I want this data. Print it, and that's it. There's of course support for content encoding. So in HTTP, they compress everything. Well, most of the time the response is compressed. Same goes in SMTP. It's encoded in base 64, all the content. So you just say, okay, you don't have to handle that in your code. You just say it's gzip, it's base 64. There is even function that will simply, you give the right header, it's going to parse it and update the tags. And if the payloads need to be processed, then it will be decoded and analyzed, etc. So it might just decode the few first bytes to get the header, get the size of the image, the EXIF data, or whatever information, and then it will just drop it. So that minimizes the CPU consumption. And yeah, so there's also the multi-part processing. So if you receive one big chunk, like an RFC 822 message that contains headers, and then a payload will be multi-part, like you'll have multiple attachment. This analyzer will create smaller payload, and if, of course, you have a gzip payload or a base64 payload, will be able to get this. So if you want to receive images from any single protocol that it's supported, it's possible. You just enable all the events that create payloads, and then all the payload are going to come to your output, and you can just act on all of them. So the outputs. There are a few existing outputs. The standard one, so log.txt to log stuff in text. So based on the template, in the template it's an XML template. You just you say, okay, I want this field, this field, this field, and I want to output this specific line. So it's very useful if you want to log all the HTTP query into an Apache log file form. You use that logs.txt, you say template HTTP Apache, and it will log everything like Apache would do. There are also other logs I can show you later on. Log XML, it's to log the events in an XML format, so you can reuse them easily. PCAP to store packets into files. It's useful because this software supports inputs that are not easily, you cannot sniff easily from usually. For example, DVB interfaces, it's not easy to sniff from a DVB interface. So with this output, you can just get the DVB packets, the MPEG packets, and tell, okay, save only the MPEG layer, the DOCSIS layer, or the IPv4 layer, Ethernet layer, whatever. So you can extract specific things with a filter as well. You have a tap output, which is very useful if you want to use other tools to analyze the traffic at the same time. You can sniff from that specific DVB interface, your Kismet drone, whatever, create the tap interface, all the packets are sent there, and you make your other tool listen on that, and it will process the packets as if they were coming from a normal interface. And file, the output file, which saves files into payload. All right, so I think it's time for the demo, if that will work eventually. Let's do it another way. Okay. So I've started it at the top, and I'll do it by hand. So what I'm gonna do now is I've got some of you might have seen the sniff box, I call it. It's like a box like this with 4 big wireless antennas stuffed with 4 wireless cards, a Guru plug, and a Kismet drone on it. So I'm gonna connect to it and see if there is any traffic and see if anybody is like sniffing. Surfing the web or anything. So first of all, the way you do that, you start your sniffer here down here with a simple command, and then you connect it to the interface. So I'll add an input. So the command is input add. You see, if I hit tab, there are a few inputs. I'll choose the input Kismet drone. I'll call it sniffbox. So this is my input sniffbox 0. That's even better. I'll add, so no, if I do input show, you can see the input sniffbox 0. It's not running. It's like Kismet drone, no packets, no runtime. Host is localhost. That's not correct. So I'll just input parameter set sniffbox 0 host, and then the host is this one, if I remember correctly. And if you want to connect, feel free to do so. All right, that's it. So no, I only have to start the input, but starting the input without any output is not really fun. So let's add some output. I've added, let's start an output, let's say the wall of sheep output. I like this one. Well, no promise it's gonna work, but so I coded that like this morning. I'll call it sheep. So output add wall of sheep. That's the type of the output, and I'll call it sheep. Output show sheep. You can see sheep. I don't know. Sorry. Output show. So you can see I've got my sheep output. It's gonna log into wall of sheep bulldog. I'll change that. So output parameters set log file. No, sorry. Sheep log file. /tmp/cheeps.log. Okay, I start the output. No, all right, let's do a more common one. I want to see all the HTTP requests as well. So output add, this one is log.txt as I explained, and I'll call it Apache logs. Logs, okay. So if I look at all my outputs, I've got the Apache log output, which the template is not set, so I'll have to set the right template. Output parameters set Apache log template HTTP Apache, and then I'll okay, the prefix is right, so I can start that output as well, and then I just need to start the input. So input starts sniffbox 0, and there we go. Okay, I don't have internet access. I forgot about that. Is there a cable I can connect to? Yeah, I can try wireless, but it's been quite flaky, unfortunately. No, I might have. No. All right, let's see. Discover, give me your new IP. You guys can't see. Okay, I got an IP address. Excellent. So let's try this again. Hopefully it's gonna connect. We'll see how it works. No, it doesn't seem to be connecting at all. Yeah, whatever. I got other capture files, so it doesn't matter. No. Connection refused. That crap rebooted. Sorry about that. Nope. Visitor, not cam, not OHM. What time is it actually? Okay. Yeah, it's down. Oh no, it's not. Okay. Yeah, it did reboot. Yeah. So I just start the Kismet drone here. I need to do a little funny stuff with the so you see just okay. So if you look, I'm not sure you can see, but no, you can't. That sucks. Maybe bigger. Still can't. No. All right. Anyway, I can't see either anymore. So I just started Kismet Drone on this box, and I can connect to it. So all right, here, what do we have? It's connected to the input Kismet Drone, and of course the network is too slow, so it doesn't work, but it found that it's got 4 interfaces, 2.4 G1, G6, G16, and 5 GHz 30. But each time I connect, the network is flaky, so yeah, okay. Anyway, that's no problem. We'll use another input. So input add. I've got some pcap files into. Let me show you. So I've been running an access point at my place, like with SSID default. All right, fine. People connected to it, fine, no my problem. Well, actually, maybe. And I've got 22 gigs of pcap files out of that. Well, of course, there were a few stuff. All right, so what can I do with those pcap files? Well, same thing, huh? You just, if I can find, so I've input add pcap directory, and I'll call it captures 0. Capture 0 is fine. Input show, so input parameters set capture 0 directory. That'll be, where is it? Okay, this guy here. And I started. All right, so there are a few files on, so it's going to take a while. First of all, it's scanning the whole directory to find all the files and put them in order, because it cannot process packets that were a day before and then a day after. So it has to because it derives the clock source from the input you're sniffing. So if you have old pcap files, the timestamp is in the pcap file. So all the timestamp that will be in the output will be the right one. They will be the one that, not the system ones, of course. Maybe I can set some debug. Come on. Log level set 4, and then yeah, you see it's adding all the packets to the list, so we can have it wait. All right, it started. Excellent. So now it's processing packets. There are a few, so it's going to take some time. Let's switch to another screen. Okay. Let's see what we have. So I started everything in /tmp. As you can see, I've got all the HTTP requests that are being parsed here, and there are quite a few. So those are all the HTTP requests it's able to parse from those data. It's going pretty fast, in my opinion. But then the most interesting file, let's see what we have in Sheeps. Oh, we already have a few. Of course, I've hidden the password a little bit, only displaying the first 2 characters. But you can see that people here were connecting through SMTP, this IP address, which was a local one, to that host. With that user, the password, it used the method plain, and status was success. So because it's able to see that the authentication worked, it says immediately if it worked or not in the logs, so you don't have to bother trying it out. All right, so it's still processing. There are 22 gig of capture. It takes, well, what is slowing down is the hard drive. It cannot keep up with the processing, so we can let it run, or I can show you how it's actually done. Okay, let me make me huge. All right, let's see Wall of Cheap. That's the most interesting one. Hopefully, oh, BG equal light, is it? Yes, okay. How does it work? Well, this is one of the Lua script that creates that Wall of Cheap output. So how does it work? Well, first you have to declare your output. So you've got output Wall of Cheap here. You say pom.output that new Wall of Cheap, and you give the parameters. It's like log file, it's a string, it's going to be wall of cheap.log, the default value, and the description is log file. And then let's go down a little bit further. You have to register your output. It's very easy. It's the output name of the script underscore register will be called when the script is loaded, and you just do pom.output register output wall of cheap. So that's your Lua class, and that's all. Afterwards, you need two functions to that class. It's open and close. Open, close. Open, you do all the. You just say what you want to do, really easily. You say that you open the log file. That you you get the parameter log file and you open it for appending. Sorry. You store it in the log file variable, and then you listen to all the HTTP request events. To do that, you just say self even listen start. You want the event which is HTTP request. So all the events have a name. They're all documented on the wiki. Nothing to do when starting the event, and then use this function when the event stops. So yeah, I forgot to say about that about the events. There always a time when the event starts and when the event stops. So you start receiving an HTTP response, and then you stop receiving an HTTP response. The main difference is that at the start time, you have more information about the packets that trigger that. You have the whole stack that triggered that, the whole protocol stack. But when the event stop, you don't, because it might be stopping because of a timer that expired, like if the TCP connection is closed. So you have less info when the event start. You have all the info when the event stop, but you don't have the packet that triggered that, because it might not be triggered by a packet. So, man, the screen is really not nice to read. Huh? I also listen to the SMTP auth even. That as well, it will call the process SMTP auth function. And that's about it. For stopping, I check if I've got a log file, I close it, and I stop listening to the HTTP request and SMTP auth event. So that is almost all of it. Afterwards, well, you have your two functions that process the event. You could have just one function and do an if statement on the event type. Output wall of cheap, process HTTP request. The data, so it's the argument EVT that is passed, EVT.data. I say data, the username is data username, password data password. If not username or password, then we don't care about this even, because there is no authentication. Client data, the client address data. So same for the server. You got the server name, the status for the status code. If it's 200, 401, you'll see immediately if the authentication succeeded or not. And simply you write into your log file found credential via HTTP using this client, this server. User is username, password is password. And status is status. Same thing goes for SMTP authentication. A little bit more complex because there are multiple types of authentications, but basically it's the same. Gather the event data, server hosts. If you don't know the server host, which might happen because it was not found in the DNS request, fall back to the server address. You also have the server hello, the value it gives when on the 220, the first message it gives. Well, that's the debug stuff. Get the username for the parameter from the specific authentication parameters, the method that was used, and you log it a little bit down. So you simply write found creation via SMTP. That's what we've seen before. Client address, server address, username, password, method, and status. Of course, this is why you don't see the full password, because I've only taken the first two letters and appended ... But basically, it's all there. So that's it. That's what you call, or you code wall of cheap. And I cannot. No, it's so far. Okay. Let's see. Okay, it's done running. So yeah, we've had a few. So you can see here it's mostly SMTP. One SMTP from an Android client with User Android, password, WD something, but we know it worked because the status was 200. Okay, what oh, Uncle Molar, nice. I might need to save those images. No, just kidding. All right. What time is it? Let's see, date. Okay, 41. Yeah, I could show one more example, but basically saving all the images I'm seeing on the internet. I'm afraid to do it with those data because I'm not sure what's gonna end up. So I might just. Yeah, right. Okay, let's try something. I'll create. So I'll stop it and create a new. Is it? You can't see. Okay. So I restarted. Of course, you can save configurations and everything. So config load. You see, I've got a few configs, which help me to test stuff. But I prefer to show the whole thing. So input add pcap interface. Yeah, I'm still not root. Blah blah blah. Export LT library. I've not done the make install, so that's why. Okay, yeah, because it's already running. Okay, thank you. Okay, so I connect back to it. So I've started as root now. Okay, so let's add an input. So input add pcap interface, and I'll call it WLAN0. Input parameter set. No, input show. So, oh, it already found out the suitable interface was WLAN0, so I can just start it. But let's dump all the files. I think I've got input output add HTTP images. I'll call it. So output show. Okay, so this output HTTP is also another script that I coded to show that you can dump images, video, and you can also say, I want that the minimum surface, the minimum size for an image is 90,000, which is about 300 times 300. But you never know if an image is going to be huge and I mean tall, but not large. So I just prefer to put the product there. So I'm going to log everything, all the images related stuff into http.log, and the log format will be the following. So output start images, input start WLAN0. Okay, let's start a browser and see if we can go on a website simply. If Firefox deems to start, come on. Okay, there we are. That doesn't work. It's good. We're not gonna. Okay. Did I lost the wireless network? Yes, I lost it. Cool. Yep. And if I can't do that. Yeah, okay. All right, nothing wants to work today. That's okay. Let's see. Do I have internet? Yeah, almost. Yes, I've got an IP address. That's a good start. All right, so you guys have a website you fancy? Wow. Okay, the stupidest website on earth. Did I start the input? Because if I didn't, then we are screwed. Where is it? Yes, it started. Output show. Output is running as well. Okay. 9GAG. Ray. All right, let's see. Hopefully that worked. Yeah, there is there are no images. Okay, fine. Yeah, okay, it doesn't work. Ah, crap. That's not very convincing, is it? Yeah, it's got packets, photo show. You see you've got all those details. So it's found 9 HTTP. There are currently 9 HTTP connection, total 18 connections you can see here. So these are all the protocols. Well, it's missing a little bit, but you have all the details about each protocol. So this might be ICMP or no, this is HTTP. So 9 connections currently happening. So it has 9 contract objects for this connection. It's seen 18 connection in total, 131 packets, and this amount of bytes. So it's quite useful to troubleshoot if you need to, and it still didn't find anything. I don't know. Yeah, okay. Well, it doesn't work. I have to check because I might have forgotten something. Anyway, let's go back to the presentation. All right, so what is the future of this? So obviously support more protocols. That is the hardest part. Each protocol is like a single project in its own. I started to code the SMTP protocol a few months ago, and I was like, SMTP, it's so easy. I mean, it's simple mail transfer protocol. It's simple. It's in the name. Well, it's not, because you code SMTP. All right, fine. You got your payload. And then I was like, okay, fine, look, I got this whole email, but it's with those crappy MIME RFCs that I've got to parse. And it took me more time to code those MIME RFCs to be able to decode all those emails, all the payloads of the email, the multi-part, the encoding. Oh, man. See, I lost my hair, that's why. So, yeah, that's the thing. Additional protocols, the next protocols will probably be POP3, IMAP, because that's the main ones being used. You can also do pretty much everything with HTTP protocol, because everything goes through HTTP nowadays. The next item on my agenda as well is better database support, because here you cannot log into a database right now. What will be cool is that text output that you've seen will just feed a Postgres database, and then you can just issue your select comments on that. So, sorry? Yeah, of course, you can connect more than one and feed one single database, or you can connect multiple inputs to a single one. It's up to you. So, yeah, and of course, the database support is modular as well. Currently, there is SQLite, but I'll add Postgres. I'm working on Postgres. I'll add MySQL, and whatever people needs can be added fairly easily as well. Additional output will be something I need to work on as well, but mostly through scripts, because that's the easiest way to create new kind of output. So I've created an add-on repository. I'm going to commit all those scripts that I've shown today. So I forgot about the cookie session stealing scripts, which is basically the same, just looking at the host name. Is it one in my list? Oh, facebook.com. Yes. Okay. Does it have the DATR and CUser value in the cookie? Yes. Okay. Store it. Might be in a database, and then you know what to do. And next thing on my agenda is whatever you wish, because I'm always always open for input. So if there are things I haven't been thinking about and you like to see, then come to me, and that can definitely be arranged. All right, thank you for attending. If you have any questions.
Check. Yeah. Hi. Very nice project. I would like to ask you a couple of things. The first one is, what is the maximum speed you reach without losing packets on a common hardware specific to have a big system to wiretap on a fast network?
Well, good question, because the problem is that the CPU needed depends on the output that you use, because if one input says I want to listen to that specific event, then the event will start to process. So I try to minimize the CPU usage as much as I can. So if something is not used, it's not going to be processed and it's just going to be skipped. So it depends what you want to do. If you want to process only DNS packets, I think it will be pretty fast. If you want to start processing all the HTTP with encrypted, compressed payload, etc., it will obviously take more CPU. So it's really on a case-by-case basis. But as you've seen, I've parsed 22 gigs of PCAP in a fairly small amount of time. So it might not be gigabit, but I think 100 megs it might be sustainable.
Is when you try to searching something in real time, so you have to in real time to find whatever you want.
Well, you can do two things. Either you take everything, you extract everything, and you look that up later, or it really depends how you customize your output. As you've seen, it's really easy to script. So if you just want to output everything, do it, save it somewhere, and then you search. But if you can do some preemptive filter before, then you know to limit the amount of data that you get, that works too. Thank you. Thank you.